All right, so we're going to talk about multiplying monomials today, and you're going to see what that means in a second. For now, I just want to talk about variables and their exponents and what it looks like. What would a model of that thing look like? So, if we're looking at the length of a line, if I drew a line, then I said, all right, that line is 5 centimeters long. Well, that's the length of the line. It's from this point to that point. It's 5 centimeters. It's one length or one dimension. Okay, so if I had a line segment like this, a line that had a length x, well, that's what it would look like. It's x. It's the length of x. Now, if I see what a square would look like, and let's see if I can make a square. Not bad. If this side was 5 and that side was 5, well, if I was going to find the area of this thing, right, that's just find the area, it would be 5 times 5, length times width. So then we have 5 times 5, or 5 squared, and that is equal to 25 centimeters squared. It's the length times the width. Length times width, 2 dimensions. Okay, and just like above here when we're talking about the line, if I have a square where each side is x, over here I said each side is 5 times 5, so it's 5 squared. So here, if it's x times x, it's got to be x squared. 2 dimensions, a length and a width. That's why we call it squared, not next to the power 2. And then if we're talking about the volume of a cube, I don't think I'll be able to draw a cube. Well, let's see. Not great. But let's say this side is 5, that side is 5, that side is 5. If we're finding the volume of a cube, we do length times width times height. This 5 times that 5 times that 5, or 5 to the power 3, 5 cubed. So same thing with this cube here. If each side is x, x times x times x would make x squared. Sorry, x cubed. X to the power 3. So to visually see what these things would be modeled as, x alone is like the length of a line. X squared is a square where each side is the length x. And x cubed would be a cube, a 3-dimensional shape where each side is length x. So that would be the 3 dimensions. Okay, so again, that's just a way to visualize what each thing means. And what we were doing here and here is multiplying monomials. A monomial is just one term. So if we go back in here, we're on the next page. And this is just sort of exploring what monomials are, or powers are, and how they work. So I'm filling in the blanks in this part here. And 2 squared, if I was to expand that out or write it out a long way, what that means is 2 times 2. And that means, 2 times 2 is 4. And if we have 2 cubed, or 2 times 2 to the power 3, that means 2 times 2 times 2, which is 8. So now down here, if I'm given this part, we got to figure out what would go there and what would go there. So up here, if I had 2 times 2, that meant 2 squared. And 2 times 2 times 2 meant 2 cubed. So 2 times 2 times 2 times 2 times 2 times 2 times 2 would be 1, 2, 3, 4, 5, 6, 7 of them would be 2 to the power 7. And 2 to the power 7 is 2, 4, 8, 16, 32, 64, 128. Okay. Now, x squared, if I write it the long way, that means x times x. Right? And we can't really simplify that anymore. That is x squared. There's nothing else to do. So that's why this side, both sides look the same. Now, if I look here, how many x's do I have? 1, 2, 3, 4, 5, 6, 7 of them. So this means x to the power 7. It's x times itself 7 times. So here, what this would mean, this part here, x squared, means x times x. This part here means x times itself 5 times. Now if we count all the x's together now that I've written out, 1, 2, 3, 4, 5, 6, 7. X to the power 7. Now, I don't want to have to write this out every single time. It would be very tedious to go through every question, expanding them like that. So, if we look at the 2 and the 5 here, what did we do? We expanded it out, but then we just added them all up together anyway. So, 2 and 5 makes 7. So, instead of writing that all out all the time, I can say that x, since that's x and that's x, to the power 4 times x to the power 8. Instead of writing it out, I can just add them up and say x to the power 12. Now that only works because they're all x's. They have to be the same base. If they're not the same base, then we can't do that. So if they are the same base, when multiplying terms with the same base, we can add the exponents. So here we are. This is what the topic is, multiplying a monomial times a monomial. So they both have the same base, m and m. The exponent is 3, the exponent is 5, the base is m. So what we're looking at here is number times number and letter times letter. Now, what I mean by that is if there's a number in front, we multiply those numbers. I don't have numbers in front. There's imaginary ones there. So it would just be 1 times 1. Not going to change anything. So the m cubed times m to the power 5 means we add the exponents. So that would be m to the power 8. Number times number and letter times letter, as it says over here, refers to this number in front and this number in front. They're called coefficients. So 2 and 5 are the numbers that I'm referring to in number times number. And letter times letter is a simple way of saying multiply the variables. So if I'm going to say number times number, I would do 2 times 5, and then m to the power 3 times m to the power 5. And this is a long way of writing it out. I'm not going to do that for the next one. But now to answer that, I would then take 2 times 5, just 10, and then multiply m cubed and m to the power 5, which we did up there. M to the power 8. Now we add the exponents. So let's do that a short way. We don't want to do that every single time. Negative 3 times 7, number times number. Negative 3 times 7 is negative 21. Now we have x to the power 3 times x to the power 4. It's going to be x, because that's what the letter is. And I have 3 of them over here and 4 of them over here. So this 3 and this 4 added together make 7. Okay, so we have practice questions down here. Please go over as many as you can, and I'll post the solutions as soon as I can. Make sure to watch the next 2 videos.